In chapter 16, we're still talking about probability. But this is stuff that maybe you guys haven't done before, and that's okay. All right, we're going to talk about random variables, which is kind of a fancy name for just kind of an idea and a problem. Okay, so some vocabulary first. A random variable assumes any of the different numeric values as a result of some random. Random variables are denoted by a capital letter such as X. A random variable defines the entire event, and then each individual outcome would be the lowercase x. So for example, this is not a really complicated example, but for example, a random variable could be rolling a die. Right, and there's 6 possible outcomes. You could roll a 1, you could roll a 2, a 3, a 4, a 5, or a 6. Right? So those are represented by lowercase x's, each individual event. So capital letter random variable x just defines what's happening, defines the event. We're talking about discrete random variables specifically right now. We'll talk about continuous random variables after the holidays. So a random variable that can take on one of a finite number of distinct outcomes is called a discrete random variable. So rolling a die is a discrete random variable. There are 6 outcomes, and then that's it. There's no other outcomes. Okay? And the collection of all the possible values and the probabilities that they occur is called the probability model for the random variable. On the assignment, a probability model for every question. That is just a table. It shows the outcomes of the event. It shows the probabilities of those associated with those outcomes. That's all it is. It's everything listed out. The ideas in chapter 16 aren't complicated. Like, we're going to do some examples in a second, which I think will make this all come together. The problem is the actual questions. So some of the problems may seem a little more confusing than what's actually happening. But the basic concept is not that bad. We're going to do an example from the textbook, like one of the actual examples they work out, because I think it helps illustrate these ideas. The book, if you read through it, if you read through the chapter, it talks about insurance, and I just generally, if I talk about the insurance example they talk about, you guys don't necessarily know how insurance works, and then it becomes like super confusing because you don't understand the context of what's happening. We can talk about that later, but this is just a more straightforward example. Okay, so on Valentine's Day, the Quiet Nook restaurant offers a Lucky Lover special that could save couples money on their romantic dinners. When the waiter brings the check, he'll also bring the 4 aces from a deck of cards. He'll shuffle them and lay them out face down on the table. The couple will then get to turn 1 card over. If it's a black ace, they'll owe the full amount. But if it's the ace of hearts, the waiter will give them a $20 Lucky Lovers discount. If they first turn over the ace of diamonds, because at least it's red, then they'll get to turn over one of the remaining cards, earning a $10 discount for finding the ace of hearts this time. Okay? I have a very specific set of things that could happen. It says model, so I'm going to make a probability model here in a second. For the size of the Lucky Lovers discount, it's important to understand what your model should look like. The restaurant award, what's the expected discount for a couple? We'll go back and talk about expected discount in a second. I just want to do the model. Okay? If you're going to create a model, you make a table. So in my table, I'm going to keep track of the possible outcomes, counts, probabilities of those discounts. Okay? I need to define a random variable. My random variable is the discount amount. That's what I'm concerned about. Okay? In my table, I'm going to list the possible outcomes, the discount amount associated, and then the probability. We write it as capital X equals X. Just needs to be notation you're familiar with. Capital X is a random variable, and lowercase x is each individual outcome. So it's just saying what's the probability that your discount amount is equal to whatever your discount amount is. So what's the probability of a $20 discount? What's probably a $10? It's just notational C, so I want you to be familiar. Okay? So if we read through the question, right, you're getting 4 aces. And it gives you some possibilities. Okay? And I'm going to do this how I would do it reading through the question. If it's a black ace, then they owe the full amount. So one possible outcome is you draw a black ace. If you draw a black ace, then what is the amount of your discount? 0. Now what's the probability that you draw a black ace? Four aces. So it's probably a black ace. How much do you draw a card? What's the probability to black ace? 50%. Right? There's an ace of clubs and an ace of spades. All right. So that's one possible outcome. Another possible outcome. If you turn over the ace of hearts, how much do you get? $20 discount. What's the probability that you turn over the ace of hearts? 25%. Right? So far, not so bad. Questions about that? Then it says, if you first turn over the ace of diamonds, then they'll get to turn over a remaining card, and you get $10 finding the ace of hearts this time. So, if you find the ace of diamonds, and then you get the ace of hearts, then you get $10. This probability is a little more complicated, so make sure you think it through. You draw, we'll do it in fraction form this time to get the decimal, but you draw the ace of diamonds the first time, so it's probably drawing the ace of diamonds. 1 and 4. And so you've taken that card and you're not putting it back. So then it's probably getting ace of hearts on the next card. 1 and 3. So that's 1/12, which is 0.083, I think. I did it earlier. I'll look. Yeah. Okay. There it is. Now, in a probability model, just like in any other probability situation ever, all of your outcomes have to add up to 100. Right? That's a rule. That's a rule we know. In this case, we've kind of talked about all the outcomes that are listed, sort of. So, do your probabilities equal 100 yet? No, we're off a little bit because there's still one more possible outcome. If you drew the ace of diamonds the first time, did you have to get the ace of hearts the next time? No. So in that case, if you draw the ace of diamonds and then you don't draw the ace of hearts the next time, what's your discount going to be? 0. And so we need to find that probability. Well, that's still 1/4, but this time it's times 2/3. So you have 2/12 or 1/6. 1/6 repeating. Questions about where any of the information came from? Then if you were asked to create a probability model, that is it. That is a probability model. It's your outcomes and the probabilities of those outcomes. I find it easier to write the possible outcomes. Really, it's just worry about the discount amount. But I have to keep track of the cards, so I like to write down the cards too. Okay? Right. Like the probability model really just needs to be this part and over. Discount amount and probability of that discount. But I have to keep track of what's happening in the problem, so I always write down the scenario. Okay. Questions about that? Now the question says, what's the expected discount? So let's talk about expected values for a second. I'll come back to this question. Expected value is the theoretical long-run average value. So it's just an average. All right? It's the center of the model. So because it's the center, we denote it with a mu for mean. It's the mean of the model, the average. We also write E of x because that's expected value. E is expected value. And it's found by adding together all the products of the variable values and their probabilities. So this formula right here is on the AP Stats formula sheet, and it's right underneath the two you used on the Chapter 15 quiz. It's the next probability formula to use. Okay? Again, it looks a little complicated, but it's not. It just means you multiply the outcome by its probability, and then you add them all together. It's pretty much a weighted average. So if we're going to go find the expected amount of discount for this probability model, because it asks what was the expected discount, you just multiply the discount amount by its probability. So 0 times 0.5 plus 20 times 0.25 plus 10 times 0.083 repeating plus 0 times 0.166 repeating. I understand that 0 times something is 0, but I'm trying to make sure that you include your work on a free response question. If it says to find the expected value, it takes like 10 seconds to write that out. Okay? Throw out your work, and then you'll get the answer. So obviously these are 0. So you're doing 20 times 0.25 and 10 times 0.083 repeating. I did that earlier somewhere. I got 5.83. So the expected discount is $5.83. Can you get a discount of $5.83? No. It's not going to be one of the answers. It's an average. All right? This is more so would be helpful to the restaurant owner. Right? They're offering these discounts. They want to know on average how much they're going to give each couple, right? Well, on average, they're only giving each couple $5. That's not really a big loss. Okay? Because again, some couples are going to take off 0, some are going to take off 20. But on average, only losing $5 per person for this one day. That's not that bad if you have a good business. Okay? So that is how you would find the expected value. Does that make sense? All right. We're going to do one more example then, and then I'll give you the assignment. You can try some of these. Okay? The first question on your homework is like this example. I'm not going to do this example. But it gives you two probability models, just not in context, and it says to find the expected value. You just multiply and add all those together. Does that make sense? Don't make that complicated. All right. We're going to do, since we just did one about cards, we're going to do the carnival example. Here we go. A carnival game offers a $100 cash prize for anyone who can break a balloon by throwing a dart at it. It costs $5 to play, and you're willing to spend up to $20 trying to win. You estimate that you have about a 10% chance of hitting the balloon on any throw. So A says create a probability model for this carnival game. And then there's actually asking you two questions. And I'm going to answer C first with my model. But so create a probability model for the carnival game and then find your expected winnings. All right. So if we're going to make a probability model, my random variable is going to be my winnings. Right? Okay. We can keep track of the outcome if you want to in this one. If it helps. And then we have how much you're going to win. And then we have the probability of that happening. All right. So again, you're throwing a dart. It costs you $5 to throw the dart. I have a 10% chance of hitting the balloon. That's the important information. Okay? So one possible outcome. You decide to play, and you throw a dart. Right? And you hit the balloon. Pop the balloon. So you paid $5 to play. You pop the balloon, so you win $100. So what's your winnings? $95. Right? Because it cost you $5 to play. You're winning $100. And what was the probability that you hit the balloon? 10%. Right? So that'd be super lucky. First try, you throw the dart, you hit the balloon. You win $100, you'd paid $5 to play, so you get $95 total. 10% chance of that happening. Questions about that? That'd be awesome. Doesn't have to happen, but that'd be awesome. All right, next outcome. You throw 2 darts because you missed the first one, but you hit on the second one. Okay? So you hit the balloon, you win $100, but you've now paid how much? $10. And so how much are you going to win? 90. Now this probability to think about for a second, it's 2 individual independent events, right? If the probability that you hit the balloon is 10%, what's the probability that you don't hit the balloon? 90. So we did not hit the balloon, and then we did. We would multiply those together. Questions about that? Then we have to keep on going, because it says we're willing to spend after $20, so you have to keep going. You could throw 3 darts, and you could miss the first 2 and then hit 1. So again, you're going to win $100, but you've now paid 15. So you only win 85. You missed the first 2, hit the third. Is that making sense? You could throw 4 darts. You missed the first 3 and hit the 4th. Now you've spent $20. So you only won 80. And then there's one more possible outcome. Miss them all, right? You're willing to spend $20 does not guarantee that you're going to hit one of them. So 4 darts and you miss all 4. That is sad. Now, what are your winnings? Negative 20, because we've been taking the money out, so you do have to put the negative 20, not 0. Okay, and then I already have all of these so that it takes forever to type things on my calculator, on my screen, so. All right, so if I want to find the expected winnings, so here's A, this is my probability model, that's part A. If I wanted to find my expected winnings, I would go through and start multiplying the amount that you won times the probability, right? So 95 times 0.1 plus 90 times 0.09. Do I have to keep writing this out? Right, so you would multiply and add until you had all of these, right? You do the negative 20 times the 0.6561. The negative 20 has to be included. Multiply all of the outcomes times the probabilities and add them all together. You end up getting an expected value of $17.20. So your expected winnings are $17.20. If you look at your model, you could win 95, 90, 85, 80, or negative 20, right? So 1720 is closer to negative 20. This is totally personal opinion, so maybe you want to play, maybe you don't, up to you. You knew going into it you only had a 10% chance of hitting any of the balloons. Just saying. Oh my gosh. Okay. So, questions about how I found that expected value or how I created that model. Now, on part B, it says find the expected number of darts you'll throw. So in that case, your random variable is number of darts. Your winnings is now number of darts. This is 1, 2, 3, 4, 4, right? So your expected value is 1 times 0.1 plus 2 times 0.09, yada, yada, because you're worried about the number of darts now, has nothing to do with the money. And so it takes approximately, well, you'll throw approximately 3.43 or 3 darts. You get around it to 4, whichever one you want to do. You can. It's statistics. It would also be correct to put 4. So, questions about the math there? You have all your possible outcomes with the probabilities. You find the expected value. Questions on that? Then on, yes? I don't know that there's a purpose. They just asked you to do it. If you were playing the carnival game, then you want to know your expected winnings.
Right.
You don't care about the number of darts. But they're just making you practice with doing it. So the assignment's on page 383, and it's 2, 3, and 4. That's just a good start to practice.